You've probably never heard about this interplanetary mission. On October 18, 1967, the USSR's Venera spacecraft entered the atmosphere of a planet whose atmosphere, when viewed from above, appeared very dense. Scientists were envisioning a world beneath that dense atmosphere, a world that was imagined to be our next home. The planet's mass, density, and atmospheric composition seemed very similar to Earth, which made scientists hopeful that they would find a second Earth below. As Venera descended through the atmosphere, it was getting readings that matched those expectations. About 52 kilometers above the planet's surface, the parachute of the spacecraft's capsule opened, and it began transmitting data related to the planet, such as pressure and temperature, back to Earth. For the next few minutes, the temperature was recorded at around 33 degrees Celsius and the pressure at about 1 psi, which was quite Earth-like, a positive sign. However, as the probe continued to descend, the pressure and temperature it encountered increased extensively. Around 26 kilometers above the surface, the probe recorded a temperature of 262 degrees Celsius and a pressure of 22 psi, which was far beyond its resistance capability. Panic ensued in the control room, and then, boom, due to extreme pressure, the space probe exploded about 24.96 kilometers above the surface. Scientists realized that the planet they thought was the next heaven in the solar system was actually a living hell. This planet is none other than Venus, the second closest planet to the Sun, where even with today's technology, landing is almost impossible. Despite this, Russian scientists, decades ago, managed to land with very limited technology under such high pressure and temperature, creating history. But how? Well, in today's video, we are going to talk about the journey to planet Venus. So hello guys, this is Brain Bargain, and let's begin another episode. Friends, the Cold War was undoubtedly the fastest progressing time for space science. The USA and USSR were competing over the Moon, Mars, and countless other places, trying to outdo each other. One of the most interesting and underrated stories is that of Venus. While NASA, under the Mariner program, launched spacecraft that aimed to pass by Venus and head towards Mercury, the USSR aimed not just to pass by but to safely land on Venus's surface and transmit photos and data from there to showcase an achievement better than America's. This aspiration led to the mission named Venera, which is the Russian name for Venus. Preparations for this began in 1961 with Venera 1 and 2, which were intended to be flyby missions rather than landing attempts. However, both spacecraft faced communication and telemetry issues and disconnected from Earth shortly after launch, leading to mission failure. Design changes were made for Venera 3, and this time it was decided to attempt landing on the surface. Since Venus was calculated to have conditions quite similar to Earth, the spacecraft's resistance was not given much emphasis. However, due to some issues, the probe's initial trajectory went astray, missing Venus by about 60,000 kilometers. Attempts were made to correct the probe's direction using thrusters, but it could not stabilize and crash-landed on Venus's surface. Soviet scientists claimed that the probe crash-landed on Venus on March 1, 1966, making Venera 3 technically the first probe in human history to contact the surface of another planet, giving the USSR a significant edge in the Cold War. But they did not stop there. The USSR built Venera 4, which exploded before reaching the surface, giving the Soviet Union a reality check that the target they were aiming for was not a garden of flowers but a sea of thorns. Attempts were made to land Venera 5 and Venera 6 as well, but they too exploded or their batteries died while descending through the atmosphere. It was then that scientists realized a major problem. They observed that when probes were dropped into the atmosphere, they initially fell very quickly. However, as soon as their parachutes opened, their falling speed drastically reduced, meaning they had to withstand extreme pressure and temperature for up to 90 minutes, which was very hard to resist. Now you might think, why not simply remove the parachute? Well, they couldn't do that either, because without the parachute, the probe wouldn't land stably and could change trajectory due to the winds or even be destroyed. Now friends, in this situation, what would you do to increase the landing speed? Pause the video here and write your answer in the comments below. So, after this, Venera 7 was built completely different from all the previous Venera probes and was made much stronger. The The vessel was constructed with a thick layer of titanium all around, and shock-absorbing materials were installed inside to prevent the extensive pressure from damaging the internal equipment. Testing revealed that this probe could withstand pressures of up to 2,600 psi and temperatures of up to 580 degrees Celsius. As a result, with so many modifications, the weight of Venera 7 reached around 490 kilograms, much heavier than all the previous Venera probes. This meant that, along with resisting more pressure, gravity would pull this probe down faster due to its design. That wasn't all. Scientists noticed that the parachute opening right after entering the atmosphere caused the speed to slow down very quickly, requiring the probe to spend a long time within the atmosphere. To address this, they tied the parachute with reefing lines made of a material that could resist heat up to 200 degrees Celsius. Because of these reefing lines, the parachute initially opened to only 19 square feet, which kept the descending speed high during the initial phase. However, as the temperature increased, the lines gradually melted, and approximately 13 minutes after entering the atmosphere, the reefing lines completely melted, and the parachute fully opened to 27 square feet. The plan was going perfectly, and the probe's descending speed was such that it was going to land on Venus's surface without exploding. However, it seemed that this spacecraft had bad luck, as just 6 minutes after the reefing lines melted, the parachute began to tear apart, and just minutes before landing, it completely disintegrated. Venera 7 crash-landed on Venus's surface at the last moment. Upon analysis, it was found that the probe's antenna had turned in the wrong direction, making communication impossible. Once again, the USSR, despite being so close, seemed to have failed. Or maybe they didn't fail entirely. Initially, it appeared that Venera 7 was not transmitting anything. However, a few weeks later, when the mission tapes were reviewed by radio astronomer Oleg Ryska, he noticed that there were weak signals for about 23 minutes on those tapes, which Venera had transmitted back to Earth. This was historic because, with this transmission, Venera 7 became the first man-made object in human history to transmit data from the surface of another planet. But this wasn't the only significant aspect of this mission. Even from that weak data, we gathered a lot of information. For instance, the surface temperature of Venus was recorded to be 475 plus or minus 20 degrees Celsius, and the atmospheric pressure was recorded to be 1310 plus or minus 220 psi, which was insane. This was enough evidence for us to understand that no matter how much technology we use, we can only land our spacecraft on Venus for a very limited time and operate them there. The crash of Venera 7 wasn't a complete waste, as it taught us two things. First, it showed that our pressure resistance could be a bit more lenient, and second, we needed to improve our cooling system to help the spacecraft survive Venus's heat for longer periods. Scientists came up with a great idea. They placed lithium nitrate blocks inside the probe. Lithium nitrate is a salt-like substance that requires only 2 joules of energy per gram to heat up to 1 degree. But when it reaches its melting point and changes from solid to liquid, it consumes about 300 joules of energy. Due to this high heat absorption, these blocks absorbed all the excess heat from the electrical equipment and prevented them from overheating. This setup allowed the spacecraft to stay on Venus's surface for a longer time. Additionally, the pressure resistance of the spacecraft was decreased to 105 bars to cut costs and fit more equipment into the probe. After all these preparations, the Venera 8 mission was sent to Venus again in 1972. Everything was executed perfectly, and on July 22, 1972, Venera 8 safely landed on the surface, sending back detailed information such as the sudden increase in planet luminosity 30 to 35 kilometers above the surface and the drop in wind speed to 1 meter per second below 10 kilometers of altitude. After landing, the lander continued to send data to Earth for about 50 minutes and 11 seconds before shutting down due to the harsh conditions. This 50-minute duration indicated that scientists had found an excellent solution to tackle the extreme temperatures on Venus. Venera 8's photometer even detected that the visibility on Venus was similar to that on Earth, suggesting that images could be captured with a camera there. For those who don't know, a photometer converts light into electric current and sends that data to Earth. The strength of the current indicates the intensity of sunlight, thus measuring the amount of light in that area. With these details known, work on Venera 9 began. This time, the priority was to create a probe that could send back photos from Venus to Earth. The probe was completely redesigned, with air brakes installed instead of a parachute and a flat platform at the bottom to ensure stable landing regardless of the terrain. To protect the cameras, they were placed inside pressure vessels with lenses at the end, capable of taking 180 degrees images. These cameras were covered with a lid that protected them during descent and popped off upon landing. Although Venera 9 had 2 cameras installed, only one functioned after landing. After years of struggle, here was the first beautiful image of Venus. Subsequent Venera missions, from 9 to 14, captured numerous pictures of Venus, and the views were so incredibly beautiful. To give your ears some relief while witnessing this history, we have also managed to obtain rare audio recordings from Venera 14's landing. So guys, this was a piece of history, an exploration so inspirational in itself that words can hardly do it justice. However, very few people know about it, which is quite surprising. We can even call it Western propaganda because they didn't let Russia's significant achievement spread, and we never found out about it. We only know where the USA and NASA have landed, where they have sent humans, but you wouldn't know what Russia has accomplished. So, let me know in the comments section below how you feel after seeing this real image of Venus. If you liked the video, do like it and share it with your friends.